My name's Tim, and I'll be talking about debuggers and how to start using one in your Java projects. This video is divided into multiple chapters. If you're rewatching this video, use the on-screen timestamps to skip to that section. What comes to mind when you hear the word debugging? Perhaps it evokes feelings of frustration or confusion, that feeling of dread when you have to spend hours looking through thousands of lines of code to find that one missing semicolon. For many, the debugger can seem intimidating and complicated, especially when compared to our trusty old friend, the print statement. But eventually, you're going to get to a position where print statements simply aren't that useful. You might get bugs that it just can't find, or you'll be looking through pages and pages full of console logs just to find that one line where it printed something useful. But learning a debugger doesn't have to be challenging. And, once you know how to use one, you'll never want to go back to print statements. Not only can a debugger help with finding and fixing bugs, but it lets you develop a deeper understanding of the code you encounter, making you a more effective and slightly less frustrated programmer. In this video, we'll be covering debugging basics in Java using Visual Studio Code. I'll show you how to set up your environment to start using the debugger. Then, I'll show you how to use it to identify and fix bugs. First, let's set up the environment.
It only takes a few clicks to set up everything you need for debugging Java. Once Visual Studio Code is open, click on the Extensions view in the bar on the left. Then type in Java in the search bar and install the extension pack for Java by Microsoft. Now you can create a new Java project by using the shortcut Ctrl-Shift-P, typing in Java, clicking Create Java Project, No Build Tools, selecting the directory that you want your project to be in, and then typing a project name. VS Code will then create an empty project and a main class called app.java in the source folder. If instead you want to open an existing project, click on File, Open Folder, navigate to the folder of the project, click Select Folder, and navigate to your source code. Once you've created a new project or opened up an existing one, click on the Run and Debug view in the bar on the left. Then click Create a launch.json file, and if prompted, click Java. A new launch file will then be created for you. Leave the default settings and return to your main class. Congratulations, you're now ready to start debugging. But first, let's take a quick detour.
Debugging your programs as they execute is a bit like tasting your food as you cook it. Now before you say anything, I promise this analogy will make sense, just bear with me a minute. If you make a recipe from start to end without making any mistakes, then you'll be fine, because you have an expected result and your food will taste perfect. But if you get to the very end and something doesn't taste right, you don't know where in the cooking process you've made that mistake, then the next time you try and make that recipe, you don't know where to look. It's a bit like executing a computer program from start to end and having an unexpected final output. We don't know where in the program the incorrect behavior occurred, we just know that somewhere something went wrong. So, instead, when we're cooking, we taste our food periodically to make sure it's coming together as we expected, that the texture's right, there's enough sweetness, acidity, and so on. Then, during one of these tasting breaks, we can observe the state of the meal before it's finished. And if something tastes off, at least we know where in the process that something went wrong, and then hopefully we can correct it. In a debugging context, we can use breakpoints to pause the execution of the program at specific lines so we can pinpoint exactly where incorrect behavior occurs. Then, by understanding where and how that mistake was made, we can eliminate that bug. Let's go to Visual Studio Code and go through an example of how to use breakpoints.
Here we have a recipe project, which contains a main class, a recipe class, and an ingredient class. The main function instantiates some ingredient objects, instantiates a recipe object, and then adds those ingredients to the recipe by calling the addIngredient method on the recipe object. I'm going to put a breakpoint at the start of the main method for this demonstration, and I'll explain how those work shortly. I'll also set my run and debug to app, so that no matter which file I've currently selected, the main function will always get called when I start the debugger. Let's click the Run and Debug button, or F5, to start debugging this program. You can see that the first line of the main function is highlighted, and the debug toolbar has appeared on the top of the editor. By clicking Step Into, we can execute the program line by line. Whenever a method is called, such as the ingredient constructor, we follow the program into it. In this example, we are following the program as it instantiates the ingredient objects one by one. While we're inside a method, we can click Step Out to return to the main function. This executes the rest of the current method in one go, then returns us to the earlier execution context, which in this case is the main function. If instead we don't want to follow the component steps of a method and want to move on to the next line, we can click Step Over to execute this method in one go without inspecting or following its steps. The code is still being run in its entirety, but we don't follow it line by line, pretending that it executes in one single command. You can see now that instead of going through each ingredient object's constructor, we execute each instantiation and move on to the next one. Notice the variables section in the Run and Debug view as we step through the main method. After each successful object instantiation, it is then visible in the section as a local variable. As these variables are objects, we can expand them to see their fields. For example, we can see the nutritional information of each ingredient object. To run the rest of the code, we can click Continue to finish the execution without inspecting each line or method. Alternatively, we can also click Stop to terminate the program, or Restart to terminate the current execution and start debugging from the very beginning. Let's add a breakpoint. When you hover your mouse to the left of the line numbers, you can see a faint red dot appear next to the line number. If we left-click this dot, we set a new breakpoint. Let's run the debugger again. And now when we click Continue on the debug toolbar, or use the keyboard shortcut F5, instead of running through the rest of the program, it stops on the breakpoint. If we have multiple breakpoints, the program will always stop when it reaches the next one. Let's place a breakpoint after the butter object is instantiated to check that its values were correctly assigned. We'll run the debugger, then continue to the next breakpoint, just after the butter object is instantiated. In the variables section, we can expand the butter object. We notice that the calories field is not correct. The calories parameter is set to 717, but is showing up as 81. Let's now set the breakpoint to before the butter object is created, and step through the constructor method to see if we can find out what the problem is. We'll restart the debugger, continue to the breakpoint, and then step into the constructor. As the problem is with the calories field being set incorrectly, let's pay attention to how it's being set. Now we can see that in fact the calories field is not being set to the correct parameter. Let's fix that and restart the debugger. This time when we run through the program, the parameters are being correctly set. This kind of bug was intuitive to spot by stepping through the code and using breakpoints. Although this might seem obvious in a small program with only 3 classes and a few fields per class, imagine a program with dozens or hundreds of classes, each with its own fields, methods, and behaviors. It would take a lot longer to check through each one individually to double check whether their constructor methods were behaving properly. But by following the debugger through the code and seeing exactly what lines of code are being triggered at each step, we can much more easily find out the cause of the bug. Instead of left-clicking, we can right-click the breakpoint dot to create other types of breakpoints. Let's add a log point, which is a much nicer alternative to using print statements. We'll add this to the add ingredient function so that a message is logged each time an ingredient is added to the recipe. Let's write a basic message, press enter. Now, when we run the debugger and check our debug console, you can see 7 new messages have been logged. We can edit the log point by right-clicking and clicking Edit Log Point. We can also add expressions to our log messages. Let's add the ingredient name to the log message so we can tell them apart. We add expressions to our log messages using curly brackets with the expression inside. Let's call the getName function of the ingredient, which returns the name of the ingredient that's currently being added to the recipe. Now when we run the program and check the debug console, it shows each ingredient being added to the recipe. This is a lot cleaner than using print statements, as we can easily disable and enable the log point, and it doesn't add any additional lines of code to the method. A conditional breakpoint pauses the execution of the code only when a condition is met. Each ingredient object has nutrition information, such as calories, sugars, and salt. In our recipe class, the total fields are added whenever an ingredient is added to the recipe using the addIngredient method. Let's set a conditional breakpoint, which only pauses the program's execution if the total calories of the recipe exceed 500. Let's run the debugger again, and we've hit the breakpoint, which means the condition must be true. Sure enough, when we expand the variable, total calories have exceeded 500. This can be quite useful, as we might only want to know the state of the recipe object when a specific condition is met.
Welcome back to my kitchen, where I've got another analogy to show you. Sometimes when we're cooking, we want to keep a careful eye on some things, for example, by using a thermometer to check the temperature of an oven or a pot of food. By keeping an eye on the value of the thermometer, we can make sure that the food that it's measuring is kept at a desired temperature range. And if the temperature falls out of that range, we can be alerted to do something about it, for example adjusting the hob's power. With the debugger, we can monitor or watch the value of variables as we execute the program. By combining watchpoints with breakpoints, we can see how a variable's value changes over time. If it has an unexpected change which leads to having an incorrect value, we can see which line of code is responsible for changing it to that value. Let's have a look at an example of this.
In this program, we've got a book class and a library class. A book contains information about itself, such as its title, author, and publication year, while the library class holds a list of book objects. In our main method, we've defined two libraries and a number of books, including timeless classics such as The Great Gatsby, Pride and Prejudice, and the third edition of Headfirst Java. So far, we've been using the variables section to monitor the value of variables and objects. What we can also do is use watchpoints, which allow us to constantly monitor the value of a given expression or variable. To add a watchpoint, open the watch section in the debug view. Then, click on the plus icon to add an expression. Let's watch the getNumberOfBooks method on one of our libraries, as well as the availability of some books by calling the isAvailable method. Now let's run the debugger. And as we step through the program, pay attention to the watchpoints as their values change throughout the program.
I hope now you've been successfully convinced in using a debugger and will start to use it in your own coding practice. It does take some time to get used to, and I know it will be tempting to go back to your old print statements, especially when we want to fix something quickly. But the sooner you get comfortable with using these tools, the quicker you will begin to reap the benefits that the debugger has to offer, especially when you get onto larger and more complex code. If at the beginning of this video you felt intimidated by the idea of adding debuggers into your own coding practice, I hope this has helped make it more accessible and a bit less scary. Thank you very much for watching. Now go out and squash those bugs.